Welcome back to how to make R play nice with the other letters. We're going to work with slightly longer texts this time, so store the word codes to get started. Now, normally you might think that we should write a loop if we're going to be doing something repeatedly, but in R, it turns out that loops are not efficiently implemented, and it's much better whenever possible to use apply. Apply takes whatever function you're interested in and applies it to each and every item in a data matrix. And you can specify whether you want to go down the rows or across the columns. So the first thing that apply takes is is the data. You can use this as.matrix to make sure the code is in the right format. Saying that margin equals 1 tells R that you want to work on the rows as opposed to the columns. Our function here, letter to number, is the one that we wrote in episode 2. And if you remember letter to number, it has that true or false toggling whether you want binary or decimal to come back. So we're going to want binary here, so we're going to put true here. So that's all you do is you write everything out, and then any extra information that needs to go to the function goes at the end. By the way, if you forget what any function requires, put your cursor right here and hit tab, and that'll bring up the options, and that'll work. That'll work whether it's up here or down there. Okay. So I'm going to highlight this. And now when you convert a number to ASCII and then to binary, or I'm sorry, a character, it's 7 bits, 7 ones and zeros. And so we have actually a one character per column. That's C, that's O, that's D, that's E, that is S. It's not quite the format we want. What we actually want is, of course, to just have all of them next to one another. And we can do that with the combine function. And there we have it. That's the kind of thing you want to be careful. You want to double check that you're getting exactly what you want. I've done that, but you might want to kind of convince yourself of that. Okay. And here's just another example of that. So now this gives us the capacity to write a function that takes texts and gives us what we want. The function that I wrote either cleans unwanted punctuation or not. It returns ASCII or not, and if you're returning ASCII, you have the option to return binary. So the output looks something like this. It takes messy, and you see everything becomes lowercase. It separates it from that big block of text. We can toggle that middle option there, and we can get the ASCII numbers. Let's see, what does this one do? That's a different word. Code's written out. And let's say that we don't just want letters back individually. Let's say that you're at the very end of you've decrypted some message, and now you want to combine everything into words again. The paste command will do that. So you're going to use the paste function and the collapse argument. When you do collapse equals those quotes there, that'll bring it all back to one word. And suppose you wanted to double check that you were really getting what you wanted. The length argument will count for you. In this case, we want 35. Again, 5 times 7. Okay, so how does it work? So we have the text that we want to work on, and we have these 3 trues and falses, these booleans. If we want to clean, then we come down here. To lower is the command that makes everything lowercase. You could equivalently replace it with to upper if you wanted everything to be uppercase. This next command is kind of hideous. It's the one that gets rid of the unwanted characters. It would get rid of any character, any punctuation you want to. Just one of those ones you want to keep handy somewhere you can copy and paste. There's no real need to memorize it or anything like that. Okay, and string split we've already talked about. Here we've got a nested if-else statement. If-else is very useful because, like apply, you can do it on entire vectors. It's just very convenient. The syntax is like this. You need You need a logical statement in the first spot. The second spot is the value that gets returned if it's true, and the final one is if it's false. So all I've done up in the function here is have one if-else statement. Then if that's true, we're going to do a second if-else statement. So if this is true and then binary is true, we're going to return this command here. And if binary is false, we'll return this command. You'll notice that these two sequences they're almost identical over here. It's just a question of whether we're passing true or false to the letter to number function that we wrote in episode 2. Now, if we don't want binary and we just want regular characters, then we'll use return like this to just give back the text that's potentially just been cleaned. And that's it. Return, by the way, is just what tells it. It's how it indicates what should be given back to the console or to the variable where you're storing the output of your function. Okay. Well, that is the end of episode 3.